So it's a very beginner-friendly introduction to what JAM is. I'd like to start this talk with naming a few things that I think Polkadot has done so far in a very novel way, and then focus on one of them. And if I look at the technological front of Polkadot, is this long statement that I have here, heterogeneous execution sharding with shared security. Let's first talk about sharding. So this is what blockchains wanted to do for a long time, execution sharding. Ethereum wanted to become a blockchain that has 64 shards, and they would all execute EVM contracts, and they would all come to some kind of settlement on a base layer. Let's first start with what is a non-sharded blockchain. So I call this a sequential blockchain. So we have the blockchain as an entity. We have all of our validators. Blocks come in sequentially. Every block that gets processed has to be processed by all validators. So the naive way to then say, okay, I want to shard this, is to look at this and say, I have this big block of validators. How about I split them into 2 parts or 4 parts? And now I can have 4 times throughput. Great, right? I would call this poorly execution sharded. Yes, we have sharded our execution, but we have also sharded our validator set. So if we split this into 2 parts or 4 parts, we're also dividing the security of that blockchain into 2 or 4 parts. And really, if I want to boil down the main novelty of Polkadot and in the technological level, is cracking this equation, solving this problem such that we can have execution sharding, but there is no longer this fragmentation of security. So it looks more like this, in that you can see now these blocks that are underneath the validators, they don't have different colors. They all have the same color of the Polkadot itself. And through this visualization, I'm trying to imply that we are sharing the security of Polkadot. And the term that we use for it is cynical rollups. In some ways similar to optimistic rollups, but it's more proactive in how different groups of validators check each other's work, and therefore we call it cynical rollups. What it brings about is this 2 properties that so far we thought they're mutually exclusive, but we actually realized we can have both. We can have sharded execution with shared security. When we split our validator groups into these smaller groups, but the security of this smaller validator group is still very high and as high as all validators, we call them cores. This is very important. So this is, for example, like the vision of Ethereum 2.0, that you have 3 shards, but they are all the same thing. Those 3 shards are the same blockchain. It's just more throughput of the same thing. And finally, Polkadot took this a step further. So it made this sharded system with shared security also heterogeneous. Now, each of those shards can be a different blockchain. And if you look at the evolution of Polkadot so far, so in the last 2 years, it's really all about making the usage of cores more flexible. So I have many examples of that here. If you want to get more out of the single core you have, this is async backing. If you want multiple cores, then we have elastic scaling. If you don't want to commit to a long period of time for how long you want to use your core, then we have agile core time. If you want to commit to not even any duration of time and just use a Polkadot core on demand, then we have on-demand core time. If you want to use this core for a non-parachain usage, that's one of the areas where JAM comes in. That's where JAM is the answer. To look at what happens in a parachain block when it's being processed by Polkadot, and then this will help us understand JAM better. The first step is that this block will be sent to this core, and this core will perform computation on it. Not by all Polkadot validators, but rather by this smaller subset in the core. We have to then create a system such that we can be sure that the data needed to re-execute this block by other validators, should they want to do it, is available. And this is where the data availability system of Polkadot comes in. And this core that executes the block will propagate this block and the information needed to re-execute it through this data availability layer. And finally, what happens by all Polkadot validators, what all Polkadot validators do, is not re-executing this whole parachain block, is in fact just updating a small signature of what was the outcome of it. But what I want to get out of it is this very interesting dualism that is 100% unique to Polkadot's architecture, in-core on-chain dualism. In that, as a parachain block is being processed, it's going through 2 different phases that have different properties. At some point, it is inside a core, so it's being processed by some validators, and this is where most of the computation happens. And at some point, it's on-chain. And by on-chain, I mean all validators are executing it. Within Polkadot, we already have this in-core and on-chain dualism. Moreover, as I talked about, we already have data availability. I can describe JAM at an architectural level as a gutting of Polkadots such that what happens in core and what happens on chain and what you put into the data availability or read back from it is up to you. And finally, with this, I can sort of conclude that JAM is an evolution of not Polkadot as an ecosystem or as a whole, but rather it's an evolution of the Polkadot relay chain. It doesn't affect things like the existence of Parachains, the governance system, the staking system, the existence of Asset Hub and the DOT token. Everything remains intact. JAM is programmable by a primitive called a service. A service is represented by a PVM bytecode. PVM is an important part of JAM, and a lot of the novelties are due to PVM. One, that it's metered. It's doing metering at a very good rate, as with little compromise. It's running at like 50% native x86 speed while doing metering, which for a VM is a very, very good number. PVM instances can invoke child PVM, a service which is itself a PVM blob, invoke Parachain, which is itself a PVM blob, and that Parachain invokes a smart contract, which is itself a PVM blob. So we can have all these nested invocations. And finally, PVM has this property where the memory can be like dumped and sort of like paused and stored somewhere and then resumed. And this is where CorePlay is intending to use this property. So this pause and resume is also something that is JAM is sort of heavily relying on and wants to implement new things with. And finally, I want to introduce a service that would likely be called Core Chains that can run Parachains. So we can move all the existing Parachains into JAM. Polkadot has most of JAM within it, excluding things like PVM that are just like, happen to be developed in the last year. Architecturally, Polkadot is JAM. It's just that it's not exposed.